moving along, why do we care about one-to-one functions? It's because it will lead us into talking about inverse functions. What is the idea with an inverse? An inverse will do the opposite of what our original function does. So, as an example, a function might take an x value of 1, plug it in, and get out a y value of 2. The function's name, usually we call it f, would look something like this. So we plug in the value 1 for x, and we get out the value 2 for y. Now the inverse will do the reverse. The inverse will take the 2, and when plugged in, will send you back to 1. And so that we have a little bit of a notation for the inverse, we still want to know this inverse of the original function f, so we'll call it f with a little minus 1. Well, the little minus 1 isn't an exponent. It means inverse. So whenever you see a little exponent of minus 1, it's not an exponent most likely. It means inverse. So when you see f with the minus 1, it means the inverse of f. So this means the inverse of f. So as an example, we have the function f of x equals 2x. So if I plug in 2 as x, I'll get out 4 as y. If I plug in, let's say, negative 2 as x, I get out negative 4 as y. What will the inverse do? Well, if the original function plugged in 2 and got out 4, the inverse is going to do the reverse. It's going to take 4 and send it back to 2. Well, the original function also took negative 2 and sent it to negative 4, so the inverse will do the reverse. It'll take negative 4 and send it back to negative 2. So, a straightforward way of looking at inverses is that you're basically switching your x's and your y's. So for inverses, switch your x's and y's. So the question becomes, how do you know whether or not a function will have an inverse? Well, here's the idea. A function will have an inverse if it's 1-to-1, meaning its y's do not repeat. So, a function has an inverse if it is, let's say, 1-to-1, means it passes the horizontal line test. No y's will repeat. Why is that so important? Because then when you actually swap the x's and the y's in the inverse, if the y's didn't repeat in the original function, when you swap them into x's, that means the x's won't repeat in the inverse, meaning it will be a function. So, making sure that the y's don't repeat in the original function, when swapped into the inverses for the x's and the y's, will make sure that the x's actually don't repeat. So remember from way back when, x is not repeating means it's a function. So let's look at an example. This first function is 5, 12, 10, 22, 15, 32, 20, 42. That's just 4 points. That's what our function is. You're worried about whether or not it's 1-to-1. If you're determining whether or not something's 1-to-1, I only need to look at the y values and see if any of them repeat. If they don't repeat, which they don't, then it, yes, has an inverse. So the question is, what's the inverse of the function f? Well, we're going to do what we were talking about. We're just going to switch our x's and y's. So the inverse will still just be 4 points. It will be just the reverse, though. It'll be 12, 5. Let's see, 22, 10. Let's see, also 3215, and last one, 4220. And again, we use the F with the little -1 because the -1 means inverse. It's not an exponent. Let's look at B now. Now, B, we wanted to again determine, first of all, is our function going to have an inverse? Well, in order to determine that, I need to look at all the y values to see if it's going to pass the horizontal line test, and it will not because we have 2 repeating y values. So it is not 1-to-1, which means it will not have an inverse. Had you tried to find an inverse, you would have swapped the x's and the y's, and what would have happened is you would have had x's repeating in your inverse, which means it wouldn't have been a function. That would have been a second way to catch that the inverse is not a function, meaning it doesn't exist.